Take it to the limit. Take it to the limit. Take it to the limit. One more time.
What is a limit?
It's when you need to stop.
A boundary.
A limit?
Yeah.
What is a limit?
Why?
What is a limit? Wait.
Sorry.
what's a
I know.
limit?
I'm trying to think. I don't know. I'm not good on the spot.
What's the limit? Tell me what a limit is. Oh, that's really mature.
Okay, a limit is basically the intended height of a function. So if the function's coming this way and this way, the intended height it's trying to go to is your limit. Whether or not that limit or that function exists right there or not does not matter.
Okay. The history of a limit. The modern notion of the limit of a function goes back to Bolzano, who, in 1817, introduced the basics of the Epsilon delta technique to define continuous functions. However, his work was not known during his lifetime. Cauchy discussed limits of causes d'analyse in 1821 and gave essentially the modern definition. But this is not often recognized because he only gave a verbal definition. Weierstrass first introduced the delta epsilon definition of a limit in the form it is usually written today.
Now that we know what limits are, how do we know if they exist?
Well, a limit does not exist if the function approaches a different number from each side.
The function increases or decreases without bound, or it oscillates between two fixed points. Appears normal, right? Let's take a closer look. What?
But in all other cases, the limit does exist.
There are three different ways to evaluate a limit. You can either look at a table, you can graph it, or you can plug it in.
Plug it in, plug it in.
The basic form of a limit equation goes the limit of f of x as x approaches c. F of x is the function, where c is the number it is trying to reach. So, the limit of x squared plus 4 as x approaches 2. Let's try our first step, evaluating using a table.
As you can see on this table, as x approaches 2, the y value approaches 8.
Or using a graph, you can find the limit as well. You can calculate when x equals 2, the limit is 8. Or simply plug it in.
Plug it in, plug it in.
She is plugging in the c value for x, and she ends with
When you plug it in,
plug it in, plug it in.
3 things can happen. First, you can get a number, which is your limit, just like the previous example. Also, you can get a number over 0, like in this example.
The limit does not exist. The limit does not exist!
That means that the limit does not exist. Or you can get 0 over 0. As you see, when you plug 4 into this function, you result in 0 over 0, which is the indiscriminant. This means do more work.
After coming across the indiscriminate, the next step would be to either factor, rationalize, find a common denominator, or distribute. Continuity. A function is continuous at point C if, number 1, f of c is existent, meaning you don't get x over 0, you just get a value. Also, if the limit of f of x as x approaches c exists, and if those two values are the same.
This is an infinite game of chess. It's never gonna end.
I don't even know how to play chess.
What? Given the function the limit of 1 over x minus 1 as x approaches 1, we get the graph, which shows that the function grows without bounds, meaning it does not have a limit. However, the limit of 1 over x minus 1 as x approaches 1 from the positive, we see that coming from this side, x works its way closer and closer to 1 for a very long time. Never quite gets there, but it goes on for infinity, making its limit positive infinity. Therefore, with the limit of 1 over x minus 1 as x approaches 1 from the negative, we see that it also grows without bound, except the opposite way, making its bound limit negative infinity. How can infinity be a limit if a limit is a defined point and infinity is not?
And if infinity is defined as without limit, how could it be a limit?
Huh. Interesting. Now that you know everything you need to know about limits, we feel obligated to tell you there may be some rare but serious side effects.
Large tumors appearing on the index fingers.
Dryness or swelling of the eyes.
Sudden urges to do things infinitely.
Or serious thoughts about dropping out of school.
Contact your doctor or local mathematician if any of these symptoms occur.
Thank you, and stay classy, Arvada.
And thanks for stopping by.
But mostly stay classy
Thanks for stopping by.
and stay classy.